So this is the. I'm going to put a title on my pages because I like titling pages, but you probably already have a title. If you don't, we can. What do you think we should call this page?
Reaction.
CO2 into water lab. I don't know.
H2CO3 level.
Okay. So as a reminder, if you already have this written down, you probably don't need to write it down again. But we put water down here with BTB in it. What's BTB? What's BTB? If you don't know the name of it, it's okay to tell me what it does. An indicator. pH indicator. It changes color when what happens?
CO2.
Say it out loud. It changes color when what happens? CO2 levels increase, but not specifically CO2.
pH.
CO2 does have that effect, but it's the pH, the acid. And the CO2 has what effect on pH, Malachi? What does the CO2 do to pH?
It can either lower it or increase it.
Do you know which one?
Lower.
Yeah, good job. So the bromothymol blue will change colors when it becomes acidic. In here, we put what? There you go. Okay. What's in here, folks? This should be a super easy question. You did it yesterday. What is it? Baking soda and vinegar. And what happened? It's no surprise. Y'all know what happened. CO2 released. Of course, we had a lid on it, right? CO2 release came down here. And what happened? We changed the pH level because why is like only one person answering this? Is this easy or is this too hard?
It's way too hard. We should just stop here.
Why do I feel like I shouldn't take you seriously?
You should. I'm trying to get a pen that works.
Is this way too hard or way too easy? Then just say it so we can go fast. What does the CO2 do in the water?
Change the pH.
Change the pH. Excellent. Okay. So, what's the data that we saw? What happened in the lab? Data that you observed was what? Color change.
Time it took. 2 color change.
How long did it take to change the color?
About 5 minutes.
Just a few minutes, right? Pretty quick, right? I guess we should say the color changed from what to what? Blue to green. Did anybody see? Ooh, that's an R. Did anybody see any yellow?
Yeah.
Where or when was the yellow?
At the surface of the water.
Why is that significant? Because the top what?
Top's acidic.
The top got more acidic, right? So like right up here, right at the level, right at the surface, it became yellow, as opposed to the rest of it, which kind of just turned a little bit of green. Is that accurate?
Yes.
Okay. And so bromothymol blue, BTB, changes colors from blue to yellow as the pH goes down. And so if you've got yellow, that means it's a lower pH, which is more acidic, right? So where does the pH get to be more acidic? At the surface. So does that tell us something about how the CO2 got into the water? Does that tell us something?
I don't get why it would be at the surface.
Yeah, why would it be at the surface?
Does baking soda drop the surface a little bit?
Did you drop baking soda in the water?
Oh no, it just boiled over, right? That's what we were waiting for.
But the liquid didn't boil over, right?
No.
Just the, like I probably should have drawn the liquid in here, right? Just the carbon dioxide gas came out.
But why didn't it go through the top? That's the shorter one.
Go through what?
The top.
What do you mean through the top?
The hole.
Well, I'm sure that some did. So I actually saw some of you guys, like after you put in your vinegar, you actually put a piece of tape over the hole. How many of you guys did that? Anybody put tape over their hole? Somebody did. Nick's group did. Why'd you guys put tape over the hole? Keep it in the cup, right? Yeah. Yeah, in fact, I have yours here, and there it is, right? Can you see that? There's kind of ripped a little bit. So, shh, y'all with me here? Y'all with me? Is he with me? So the yellow at the surface means that where was the carbon dioxide getting in? Yoo-hoo, is this hard or easy? On the top, right? All right, so it got in at the surface. All right. I think we got everything covered there. Let me just make sure. My notes. Oh, and then I guess I was going to write this down. Took a few minutes. Okay. What I want to do is I want to talk about this and say, okay, we've got some ideas about what makes the carbon dioxide get into the water. Like what's causing it to actually physically go in.
Reaction between the vinegar and the other.
No. Like when there's like,
ceiling.
Look, water, carbon dioxide. Like what actually makes that particle go down inside?
Yes.
What are some ideas y'all had?
The high density of the.
Are writing this in our notebook or just?
We're just talking about it for a second here. I'll write something here in a minute that you should write.
The high concentration of CO2.
High concent, like just the fact of having a lot, like that's significant, right? Right?
Yep.
Okay. So having a lot of it is significant. Having a lot of CO2 helps it go in. If you want to write the words down, you can. If you prefer to just wait a minute and then draw it accordingly onto your beautiful picture there, you can do either one. Whichever way you think would help you learn it the most. What other facts might cause carbon dioxide to actually go in the water? Little kind of example for you. Suppose you're standing by your car and then you get into your car. Like what has to happen to make the decision? Like why don't you just keep on standing there?
Because you need to leave.
Because you want to, right? Does carbon dioxide want anything? Does it have a brain? No. So can it literally like make up its mind to go in the water?
Yes.
No, it can't. So something has to cause it to happen, right? Have we talked a lot this year about particles moving?
Yes.
Yes. So what's something that could be actually causing it to go in?
Pressure.
Pressure. And by pressure, you mean what kind of pressure? Where in this class did we measure pressure? We measured pressure of what?
Gases.
Pressure of gases. So in this situation, it would be gases. Like what gases are we talking about?
Carbon dioxide.
CO2 in the
container.
Well, but in the real world, we would call that in the
Air.
There you go. I knew you could come up with that. Okay. There's actually a really important idea in chemistry called partial pressures. And the idea of that would be that some of the pressure of the air is made from carbon dioxide and some of it's made from nitrogen and some of it's made from oxygen. Like all of the different chemicals that are in the air would add together their pressures to make the whole pressure. That kind of makes sense, right? So that's something there. When there's pressure, what is pressure caused by? Anybody remember what's pressure caused by? What?
The amount of particles and how much space there is.
How much space there is. And particles doing what?
Moving. They're hitting the wall.
Hitting the walls, right? So what could be a cause of carbon dioxide going into the water?
Not temperature.
What?
Temperature change.
Could be a temperature change. But like when you've got, like here, look. Here's your water. Here's your carbon dioxide. It's going all... I shouldn't have drawn it that way. That's a terrible way to draw that. Never mind that. Here's your carbon dioxide, like one big one. And it does this. Because it's moving, right? Yes. What's it do? What do particles do when they move? They collide. They hit each other. Right? What else can this thing hit? The water. What happens if it hits the water? It might go in. Right? After all, what happens if you hit the water?
You die. If you hit it too hard.
If you hit it too hard. But you go in, probably. Hopefully you don't die, right? So you go in. You think the carbon dioxide could do that, right?
Is the water frozen?
So moving particles of CO2 hit the water. Okay. Hey, what's another thing we've talked about in this class that would make carbon dioxide do something? Heat. What about heat? Yeah. Ooh, maybe like higher temperature. Because what does higher temperature mean? It means the particles are doing what? Yeah. Means faster CO2. Hey, do we in our world nowadays have a thing going on about how air is getting hotter? Yeah, that's happening, right? Higher temperature means faster CO2, right? Does that make sense? Does anybody remember anything we talked about before about positives and negatives? They what? Yeah. Positives and negatives attract, right? Did you know that one side, the oxygen side actually of water is negative and the hydrogen side is positive? What? Sometimes we draw it like this. Does that make sense? Could there be an attracting thing going on here? There sure could, right? So there's some good ideas for you. So the next thing I want you to do is to take your picture here that I gave you, this one here, and I want you to take the ideas that you made as you were talking in your groups, and also these ideas that I just helped us all to come up with here, and come up with a best possible, most thorough explanation here. Now listen carefully. Thou shalt not draw in the circle CO2 unless you're using that to mean the particle. This picture needs to have particles in it. Does that make sense? So, do some drawing. So, connection to oysters is what? What's the connection to oysters?
Oysters die.
Oysters die because?
Because carbonic acid.
So the H2CO3 acid kills oysters. Right?
Yep.
There's a connection, right?
Yep.
Hey, several groups came up with this really interesting realization that the acid level, like in the cup, the acid level was the highest right at the top. Right? What connection does that have to oysters in the ocean? Oysters live where? Where do oysters live? Near the top, in the shallow. They don't live down in the deep, 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 deep parts of the ocean, right?
They do.
We're talking about up at the surface, which is there's higher acid up there. Sound good?
Yep.
All right.